Hi everyone, this is my first lecture on linked list. So in the linked list we have many different types, like we have single linked list, double linked list, circular linked list. First we'll explore how a single linked list looks like. So every linked list you can see as the same manner. So let's say let's consider this is a structure of linked list. So there will be a node and it's divided into two parts. So this is single linked list. Yeah, ignore my writing. This was the first time I'm writing on whiteboard, so you can ignore. Let's consider this as single linked list. So now one part of the value will have your data and the other part of the value will be a pointer to the next node. I mean, like if you have another node like this, then this will be the pointer to the next node. Okay, so how do we implement it? Let's say now as we are going with Go, so Go has something called structs where you'll implement this. So we'll see the implementation a bit later, but let's understand how this data structure works. So now let's say there is a node and in this node there will be a value. Let's insert a value 23, and when you insert a first node, that in the entire single linked list series this was the first node, then the pointer will be nil, right? So there is no next node, so there will be the pointer which is nil. So in Go we say something you have may encountered in different languages, like in Python we call it as none, and in Java also we call it similarly something called null, I guess, and in TypeScript and JavaScript we call it as null. Yeah, so you can ignore for now, and as we are going only with Go, you can consider the Go value which is nil. So nil is a value for there is nothing there. So at the first we'll initialize this value to nil and this will be the data value. Okay, and let's say now we connect this particular node to another node. Let's consider this is that node, and let's say this node contains 33 value, and now the pointer of this thing will be nil, right? Because it is not connected to any node next, but this particular node is, we should connect this node to this node. Let's say this pointer has a value of 1 2 3. This is a pointer 1 2 3. So now this value will remove as nil and will assign p 1 2 3. So if you consider, we are not storing the direct values here, that means we are storing just the pointer to this particular address. Let's say this, the exact location we can't determine, but we can have an approximation. Let's say this is present at an address ADD123, then there will be a pointer, right? So there will be a pointer which points to this address where we'll find the original data, right? So this node, like this pointer, is a pointer to this particular node. This is not the exact location where the data is present. This is just the pointer. Like let's say x equals to 23 and address of x, I mean and of x, will give you the pointer, not the exact variable. Let's say you store this particular value y equals to and of x, then that means you are just storing the pointer to the value x. Now how do we access this particular value? Star y will give you the value of x. So now y is a pointer of x, and when you use it with star, then it will give you the exact details of the data. So now we have understood about how a linked list is present, but let's see what different operations are present on a linked list. Let's say this is a particular node, and now this we have a value 23. That means this can be considered as head. Okay, so now this will be the head of the node, right? And what will be the first thing? Let's say now we'll consider a head variable which will be initialized to nil initially because there is no head, and let's say there is a variable called tail which will be the nil, this which points to the end of the list, and this will point to the start of the list. Okay, you can consider this both. So now let's say this will be the head, right? And what is the first value? This is the tail, so the tail will be pointing to here. Okay, now let's say we insert another node, then that means we insert a node something called 23, and sorry, my bad. So let's insert another node called 33. Let's insert a node something called 33. This will be pointer, let's say 33 to this pointer, and this will be nil, right? So now the tail should be this, and head will still remain as this, right? And even let's say we insert another node, let's say this is one node and this is one node and this is a third node. So this here, tail points here and head still points here. So yeah, this is how a linked list works. So but how, let's say for an interviewer, he says that just implement basic functionalities, implement basic functionality of a linked list. So this is your question. So how what are the different basic methods which you can implement in single linked list? So that you need to tell to the interviewer, right, before you start coding. So let me tell you what operations we can perform in linked list. So we can insert a new node, right? We can either insert a new node or we can delete a node, right? And either we can say, let's say interviewer call the length, then we can give the length of the list, or we can print the entire list, or we can print the entire list, so these are the basic operations, right? So these are the insert node, delete node, length node, and print me the entire list. And the other thing can be like find me whether this particular value is present or not. So let's say that will make it as a find function. So these are the functions which interviewer asks from you, like to implement if he wants whether you know a single linked list or not. So for that you need to know all these functionalities. Now we have understood the basics of linked list, right? You have understood the entire basics like the structure and how the head and tail pointer is maintained. So now we'll see what individual function does in the next slide, or maybe next whiteboard. So let me clear this whiteboard first. So before getting into the functions of linked list, so first we need to understand how we'll represent this particular linked list in Go. So what are the basic components of linked list? So there is a node, right? This is a node, and in the node we have something called data and something we have called as next, right? Something which is pointed to next. So this is a pointer. So this is the data. So let's say for now we'll only store int values. So let we place this as int, right? And the next. So what type is the next pointer? So let's say this particular node is of type node, right? Let's consider this is as a node. So let's say if this is connected to a different node, this will be the another node. Then what will be this pointer type? This will be node, this will be star node, right? So this is of type star node and this is of type int. So for now it is on your use case. You can implement any of the type here, either int or you can use strings or you can use list. It's your wish. But for now, as we are implementing single linked list, let's start with the basics. So this will be the data, okay? And if and we already realized that next is a star node pointer, and we also have something called head pointer, right? And we have a head pointer and we have a tail pointer which points to this, the end of this linked list. But if you see on a high level, if you see it properly, this is an entire single linked list. So this node doesn't represent a single linked list. This entire thing represents a single linked list. I'll write as SSL, SLL, so it will be long to write. But this is a node. So these two are different. And if you see properly, SLL contains head and tail pointers. And these head and tail pointers are pointing to the real node structure, right? Yeah, this may be a little confusing to you, but if you see on a global level, it is like this is a single linked list structure and this as an individual nodes. These are n1, n2 and n3, and this in a single linked list. And now this is a tail, sorry, this is a head, my bad, this is a head and this is a tail. You got it, right? So it's a one struct which is outside, which is an SLL, and the other struct was n1. What I mean is, you implement functions not to the node, you'll implement functions to the single linked list. So there are no functionalities for a node, right? See, node itself, it's a thing which is created to store the data, but the actual functionality is present in SL. So that means, so let's write the basic structure which you can get it. So there will be a type node, right? It's a type node struct which is of type struct, and this will contain a value data, or we can say we can use value also. It depends on your naming convention, but for now I'll use as a data. And this will be the type int, and the next value will be next, right? Or you can keep next pointer, it's as you wish, but most of the people use next. And this is a type node, as we discussed before. So now this is structure of node, but how will SLL will be present? So let's consider type, and this will be SLL, or you can consider, you can write your own naming convention, and this will be of type struct. And now here will contain a head pointer, right, and a tail pointer. So what is of types of head and tail pointers? This is of star node, and this is of star node. And now all the functionalities which we create will be present on this type, not this type, right? Like, see, for implementing linked list, you need to know some basics of Go, like how inheritance works. It's better you follow my blog. Like, I have written the entire blog on basics of Go, so you can read that and later come here. Or if you already know the how Go inheritance works, then yeah, you are at the best place. You already know something, then you can start understanding the concepts of single linked list. But I recommend you, better you go and understand how inheritance works. If this you didn't get this how inheritance works, then you'll face a difficulty in writing the code when you convert the logic. Like this is a single linked list, right? You'll convert this into code in Go, and if you know the inheritance, now it becomes easy, and it becomes easy for me also to tell that if I refer some concepts, then you'll get it instantly. So yeah, so this is how you represent a particular single linked list and a particular node. And now we'll see individual functionalities which we discussed in the previous whiteboard, like inserting a node, deleting a node, finding a node, length of the node, yeah, something like that. Let me clear this whiteboard again. So first let's see how an insertion of node works, right? So we have two things, so we'll keep SLL. In this SLL we have head and we have tail. I won't be using the full forms because it's difficult to write. And in a node we contains something called data, and will something called next pointer, right? So I'll keep this as next, so to keep it clear. Okay, so now for the first time, let's say for the first time this head, so hear me out, this head will be nil and the tail will be nil, right? So let me write what we are going to implement here. Insert node, this function we are going to implement. How we are going to implement, we are able to will be seeing this, but the entire code will be discussed at the end of the video, so I can't show you the part of the code and then later this. I'll show at the end of the video so you can recall everything. Okay, for the first time, let's say there are no nodes, right? Let's say there are no nodes. So what I'll keep the pointer head, tail. Okay, so there are no nodes, so this will be nil and this will be nil. Okay, so let's say there is one node, and let's say this is that node, and this particular, let's say this particular node is present at the address A1, and to that address P1 is a pointer. Okay, so now let's say this particular value is 2 and this will be nil, right? And now where will the head be pointing? To this pointer, right? So this will be pointing to the P1. And where will be the T will be pointing? This will be the same, right? P1. And let's say when another node is added, so So let's say a new node will add here, which is 2, which let's say it's a pointed p2, and this particular node is pointed to this node, which is 3 p3. And now what will be my head, which is pointed to p1 only, right? But the tail is incremented, so we are basically making tail equals to the new node which is created, which is p2. This particular node has a pointer p2, so now this will be made to p2. So now let's say now we add another node. Let's say we add one more node, and this will be a pointer p3, and this will be a pointer p2, and this will be a pointer p1. So where will my head pointing to? p1, right? But where will my tail pointing to? It is p3. So basically we are incrementing as a new node comes. So what we need to do first? First, when a new node comes, check whether head is null. If head is null, obviously tail will be null. So you can keep a single condition where head is null. So if head is null, then make, like, let's say you have considered the 0th position, you have created a new node. And now to this new node you have something called, like, let's say it's a pt pointer. So this is a pointer to it. And now check whether head is null or tail is null. Then that means you can simply assign your head to the new pointer, right, which is pointing to the new node. Yeah, and then tail will be the same. You can assign to head or pt, which is same, right? Its head is pt now. Now let's say head is not null and tail is not null. Then what's the next step? You have the pointer pt, which is pointing to the new node. Then you can, it's simple, right? You can first, but you need to understand this. So let's say, so now at the initial stage, let's take this example so that you'll understand it better. So before it, the tail used to point here, right? And head used to point here. So now when a new node p3 comes, what you need to do? Let's consider this node. This particular node, initially it will be null, which is, let's say 3, this is 2, and this is pointer p2, and here a tail is pointed, right? But now if you see, if a new node comes here, which is 3, which is null, and this is a pointer p3, then what you need to do first? First you need to point this particular node, which is p2. This is the next, right? You need to point this particular next to the p3, and then later you need to move the tail, right? Because if you move the tail first, then you won't have access to this particular node. So before moving the tail node, first you need to make tail dot next pointer will be pointing to your new pointer pt, and then later you need to move the tail, right? So either you can make tl as pt, or which usually everyone makes is like tail will be tail dot next. That's it, right? It's the same, because you have already pointed this particular tail dot next to pt, which is like you have pointed p2 dot next to p3, right? So this is similar to this functionality. So you can simply point tail dot next, which is here, to this p3 node, and then you can move that, you can increment your tail pointer, which is here, and that's it, right? This is the end of the function. So this is that simple, like inserting node is that simple. And now we'll discuss how we can find the length of the linked list. So yeah, what we are going to discuss, it's length of SLL. It is a lot more simpler than insert node, right? So let's see how this works. Let's say we have already a particular single linked list constructed for us. So now this is head and this is tail, right? Okay, so now how you will find length of, let's say they gave you a beads, like they gave you one bead, second bead, third bead, and fourth bead, and these are connected. So basically what you'll do, you'll keep your finger here, count 1, and next you'll move the finger to your here, and you'll be count 2, and here count 3, and here count 4. So when you don't have no beats, then you won't count it, right? So simply the count will be 4, right? In the same way, you will count the length of the single linked list. Let's say you keep a temporary pointer here. Let's say keep a temp pointer which points to your head, because that's the starting of your single linked list, right? And you keep a small count variable, count equals to 0. Okay, so now when you found a node, then you'll increment C++, right? It's not C language, it's just we are incrementing one, so I'll write C plus equals to 1 for better understanding. And you'll move this temp pointer to the next node. How you will move a temp pointer to the next node? Temp pointer dot next, temp pointer equals to temp pointer dot next. That's it, right? If you want to move to the next node, because they are connected, then you can simply point your temp pointer to the next, to the current next, right? Then you'll find this one, and you'll go here, and now temp pointer will be pointing to this particular node, and you'll increment by 1, which is this one, which here count marks to 2, and here count marks to 1, and then you move your pointer here, and the count increments to 3. And as this particular temp pointer, when you mark it, will be nil, right? So you don't have your any further nodes here, so you won't move further. Then that means it's simply like until you have temp pointer, until a temp pointer not equals to nil, you simply move your pointers, right? You simply increment C plus equals to 1, and you'll keep as temp pointer equals to temp pointer dot next. This will keep on a loop, and you'll just return. See, this is that simple. It's not that hard as insert node. In insert node, you need to move your head pointer, you need to move your tail pointer. If you don't have if it's a starting node of a linked list, then you need to point your head pointer to the tail pointer. So this is that difficult. I'm postponing a little bit of delete node, because delete mode is a little bit complex, so we'll discuss at the end. For now, we'll complete all the basic operations. So this will be the length, and next we'll discuss how to print a single linked list. So already in the previous discussion, we have discussed how we'll find the length. So let's see how we'll print. We will print the list. So don't you seem similar? In the previous, what you're doing, you're just moving, you're placing a temp pointer to here, and you're jumping to the next node, right? You're jumping to the next node here, and you're jumping to the next node. Don't you see the similarity between these two? It's like you're accessing this particular node, and you just in the previous thing, you're just incrementing the count, right? Instead of incrementing the count, can't you print this particular node's value? There's a list, right? So you can simply keep a temp pointer as previous, and you can move one node to the other, and you can simply call format.println, or you can use print access by a space. For now, I'll be using this, and you can simply access temp pointer, and you can access temp pointer dot value. And you need to observe that temp pointer is a pointer, not an actual address, like not actual value. Okay, so this doesn't seems to be this node, so you should not use this type of thing. You need to use star temp pointer. Now this will contain this particular node, and then you can access dot value or dot data as we discussed. You can use anything. For now I have used value, so we can use value. So you need to extract the entire node struct from this particular pointer, as discussed previously with an example. If x equals to 23 and y is pointing to ampersand of x, then that means star y holds a value. Y only holds the pointer of the pointer reference to this particular x value. Then the same way you can use star temp to access the value, and you can just print the value. So now let's discuss the most important topic, which is deletion of node. So let's discuss how we'll proceed with the delete node. So delete node, in the sense, it's not directly deleting whatever random node. You will pass a value, something called x, or people will call this as key, which you want to delete. So let's see what are the scenarios in which the deletion takes place. Let's consider these nodes. I won't be writing those boxes because those are hectic, right? This is this way. So head will be pointing to this particular node and tail will be pointing to this particular node. Let's say this particular key is of this node. Let's say you want to delete this particular node, right? So this is some random particular node which you want to delete. Let me roll back some changes. It doesn't look good. Yeah. So let's say this is that key element which you need to delete. So how would you delete this particular node? It's direct, right? If let's say you have a pointer to the previous one, let's say this is a previous node, this is a previous pointer, okay, then you can have something called current pointer. Okay, so after having your current pointer, you can simply point this particular previous pointer ka next. So that means this has a next pointer, right, which is pointed to this particular node. That means this particular node. Okay, simply what you can do is you can break these links. How? Just you need to point this particular next to this particular next. Automatically this node is ignored. That means this particular node is not used anymore. Then you have simply deleted this particular links, and so the new will something become like this one and this one, and your head will be pointing here and your tail will be pointing here, right? Okay, so this is a scenario. So what would be my next scenario? Let's say this is another node and this head points to here and tail points to here. So now let's say this is that particular key which is tail, right? So now here you'll have your previous pointer and this will be pointing your current pointer. Okay, so what you need to do, you need to make your tail, this particular tail, to be removed. You need to delink this, right? So simply what you can do, you can simply keep dot next equals to nil, right? And you can simply point your tail to your previous pointer, which seems right. So then this particular node is converted into this thing. This particular node is converted into this thing, which here it points to head and it points to tail, right? That's better, right? So now let's say you have this particular node. Okay, so it's my bad. This particular node, and now head is pointed here and tail is pointed here, and now you want to delete this particular node which is head. That means your current pointer will be here, and what's the previous pointer? What will be my previous pointer? This will be pointing to nil, right? There is no previous pointer here, so this will be nil, and this your current pointer will be pointing to head. So simply what you need to do, you can simply first you need to know what will be my head, right? Head will point to current pointer dot next, right? And what will be my current pointer dot next? Current pointer dot next will be nil, right? This will be nil. So that means you are breaking this link, but before breaking this link you need to know what is the second node, right, to point it to the head. So then that thing would be this particular thing. Then you need to do this, and yeah, that's enough. So what is the other scenario? The head where the single node is present, which is head and the tail. So you do the same, right? Current pointer and your previous pointer will be nil, right? And now on this nil, then you'll check whether this current is both head and tail. So yeah, it belongs to both head and tail. So then that means you'll simply make head pointer to nil and tail pointer to nil, right? That's it. It's that simple. I know there are too many cases which you need to understand, but these are all the cases which it covers. So it's that simple. yeah, you can go through again. If you have any doubt, you can simply put it in comments and I'll communicate with you there, and you'll have a detailed notes of entire this thing in my blog. So as you know, which I said in my introduction video to DSA series, I'll be preparing a blog which I'll be sharing with you all, where you can refer to my regular lecture notes. So after this particular lecture, I'll be posting the code, like the code where you can practice, like lead code or Geeks for Geeks links, and then I'll post a explanation there, or else you can comment there to that blog, so I can reply there, because it's better if you comment on blog, because I'll be active in Medium, so I'll be giving a reply there. So yeah, this is how you solve all the functionalities. So when you say all these, no, then the interviewer will be impressed, because you're handling almost every case, like you're detailedly explaining what you are gonna do. And yeah, that makes it simpler. Like, you know something and you're better at explaining. If you explain it better, then that means half problem solved. Yeah. So now, yeah, that's what I want to learn from teaching you. Like, I'm not basically teaching you, I'm just explaining how I learned to make this concept easier to me. So that's how I'm teaching to you. And then next we'll be seeing the code. So code will be a walkthrough, not the entire coding session, because it takes time. If I code, my typing speed is around 40 to 45 words per minute, which may make you feel asleep, like it's not an ASMR video. Like, I'll just give a walkthrough to the code, and because as you know the concepts, you need to be able to do the code, right? See, it's not me showing you the code. It's like you should understand how to convert this entire logic into the code, which I learned. I never see lectures, I never seen the code. I'll just see the lectures and I know the logics, right? Then from there I'll write the code. If there is some issue, I'll ask ChatGPT. That's what everyone does. It's better now. You need not go through the entire internet to find your problem. They can simply ask the ChatGPT, right? So now in the next, it's not a whiteboard session. It will be an entire VS Code session. Just I'll be showing you how you can structure the code, how you can write SLL, how you can write a node, and it's your wish. It's your own pattern which you can follow. If you're of other language which is not from Go, then you can skip this part and you can simply directly code in your own language, or refer some blogs which is written in Java, Python, or something. Okay, right? Let's go to the coding session. So as I said, I'll discuss about the coding session. So yeah, you can consider this as a simple coding session. So this is a Vim editor which I use. So it's basically, you can use any of your text editor. You can use your VS Code, Sublime Text, or something, but this looks simple. So like, this don't have an autocomplete, so you need to code everything, so remember the entire syntax, which will be better to you, right? So now, yeah, which I said, this particular file contains a single linked list. So insert value, delete value, find value, length, and print list. So first, so before that I said right, so you need to know some basics of inheritance, which you need to understand in Go, so that you can understand it better when I discuss with you. So let's say we'll declare a type which has all these implementations, like insert value, delete value, find value, length, and print list. So this will be a linked list. So every base linked list, like that means if you use a double linked list also, the same functions remains, right? You will insert value, you will delete value, you will find value, and you will do length, and you'll just do print list. So I forgot to add the print list, so simply I'll add the print list here. Yeah, it seems better. So now I'll just add my classes. These are abstract classes, abstract functions, so these do not have any implementation here. And then you'll have this particular node which we discussed. It has a value and it has a node, right? And this is the outer class, outer struct, basically single linked list, and you have head pointer and your node pointer. Okay, so let's discuss about insert value. So first, whenever a value comes, like you will be inserting a value, right? From that value you will create a new node, and from this new node, first check whether this particular head node is nil or not, right? So if the head node is nil, then that means your tail is also nil. Then you will simply assign this sl.head to the new pointer, to the new node's pointer, and you'll do the same with sl.tail will be your head, and this sl.tail.next will be the new node, and sl.tail next. That's it, right? That's simple. Okay, let's see how we can delete the value. So which I said, previous node will be a start node, which will be eventually the default value will be nil, and your current node will be sl.head. So now you'll traverse under the current node will not become nil, and if the current value, like the current node's value is equals to value, then you'll break it, right? And let's see the conditions which we have discussed, around 4 conditions, right? So let's say if this particular current node is an head node and also a tail node, that means only one node is present, then you will make sl.head and tail as nil. And if the current node is head, the node which you are going to delete is a head thing, so then you will just point your sl.head to the current code.next. That's it, right? Just point to the next thing, so you are simply ignoring that particular value. And if you want to remove that next null pointer also, you can simply make your current node dot next to be nil. So this is better, right? So which we discussed as before, we need to make that previous pointer, like previous connection, to break. And if it's a tail, then what we'll do, we'll make the previous dot next to current dot next, and we'll move this particular pointer to the previous node. What if in other cases it's simply moving the previous node dot next to the current dot next, simply the loop will break, right? This is what we are doing. And now, yeah, by this you have understood the delete value. And how do we find the value? We'll simply make a pointer to head and we'll loop until it's nil, and then that's it, we'll find a value. If you found a value, then you'll simply return true, like if the current value is true. And if you don't found that particular value, you'll return false. And let's say now you'll try to find the length. It's simple, you'll increment the count, which is length equals to 0, and you'll increment and you'll just return the length. How you'll print a list? It's similar to the length. You'll simply loop the entire thing and you'll print the single note value. If you see here, something looks off, right? Here, when you are accessing your value, which we discussed in the previous thing, right? So we need to access like this, right? Current node dot value, not current node dot value. If you know the Go concept better, then you should be able to understand that Go automatically dereferences the struct, right? So even the current node dot value seems the same, and these both are same. You can either use star current node, which makes you understand better, but you can also directly access the value without going to the address and everything, because Go knows if you are using dot value, then that means you are trying to access the value, not pointer doesn't have a value, right? So you are accessing the particular struct's value. So that way the Go works. And I'll be sharing this entire repository with you in the description, so you can see the code whenever you want. Yeah, that's it for now. So we have got the basic understandings of how single linked list works and how you need to code from scratch if someone asks you, or if let's say your brother asks you. They are even learning, right? So now even if an interviewer asks you, you should be able to implement everything from scratch. You can choose your own language. It's my favorite language is Go, so I want to learn Go. Basically not favorite, but yeah, I'm liking it, so I want to learn Go, so I'm implementing everything in Go. You may think that I can have a live coding session, but coding this entire thing would take time. Then we'll have a learn together like something, so we'll be keeping a 3-4 hours meet and we'll be learning something randomly. But for now, yeah, please adjust with it, and I hope you like my videos. So make sure to subscribe and like this, and if you found something wrong, something not good, or some ways we can improve, then please make sure to comment in the video. Yeah, in the next thing what we are going to discuss in the next thing is, like, we'll explore different problems of single linked list, and from there we'll go to double, and yeah, we'll follow the roadmap in the DSA series itself. So yeah, we'll discuss different problems which you may encounter while you are going through an interview, or like it's a basic DSA, right? You need to know how you can solve the problems. Not knowing the basics is enough. So we have known the structure. Yeah, now you are good to go with solving the problems. So we'll discuss different problems in the next video. So it will be like one problem, one video. It's not going to this long because you should have a basic understanding, so I took this long. But there will be only the problem explanation, and I'll be showing you the code. and you can have the links in the description, and you can simply go there and practice it, right? Hope you like the video. So hope you have a good weekend. Yeah, it's already Friday, so I'll go watch a series. Yeah, you do the same thing, right? It's meant to enjoy, learn and enjoy. So right, yeah, that's it. Bye bye, have a good night.